right, so in this section, we've made our network more efficient. We've done this by getting rid of the multiplication by 1, because we don't need to, because it doesn't change anything. We've gotten rid of the processing of any of the words that have zeros in them altogether. And this really should increase the speed of both the training and the testing of our network, and the running of our network by a significant amount, which we'll find out in a second. Now, in order to make this change, most of this top part of this class didn't really change, right? So we still initialize the network, we still create the same weight matrix, still create the same word to index lookup. I left these methods around, but we're not going to use them. And then when we get to this train method, some things really start to change. So I added kind of a pre-processing step to the train method, which was the following. It takes each of the kind of training reviews raw, so the raw text, and it creates a set, which it converts to a list later, of indices. So it converts all the words to numbers, right? But to the rows that they correspond to. So in this case, it's like what we did up here with this 4 and 9, right? So then we had this list of indices, and we can just sum them into this vector. And this ends up being really, really fast, which is great. So what we did here is just a kind of a bigger version of that, where for each review, we convert the words to the row of our weight matrix that it corresponds to, right? So our inputs correspond to rows in the matrix, and our outputs correspond to columns, right? So in matrix multiplication is kind of how it works out. And that allows us, when we get down here, to completely skip generating our input vector, right? So we don't have to do that in forward propagation at all. We jump straight to generating our hidden layer, and all we do is we iterate through each index in our review, so each index, and we sum that row of weights 0, 1 into layer 1, right? So we take layer 1, which has been emptied out right here, and we say, all right, for each row in weight 0, 1, add it into layer 1. What we're doing is we're saying for each row, add it into the hidden layer. So add the row for horrible, which is this one, add the row for terrible, which is this one, add it in here, right? So we're skipping this entirely, and the 70,000 other words that weren't mentioned here. That is a huge, huge time savings. I think I'm really excited to see how much speed that gives us. Now this part's exactly the same. Layer 2 error is exactly the same. Layer 2 delta is exactly the same. Layer 1 error and 1 delta are exactly the same because nothing's changed. The only thing that's different now is the way that we update the weights is basically just the inverse of when we populated it. So we iterate through the same indices and we say, all right, we're just going to update the ones that we forward propagated, the ones that we used, and we're going to leave all the rest of them alone. This actually makes even more sense when you look at how backpropagation happens, or how the stochastic gradient descent algorithm happens, right? So you have when you're computing this final weight delta, your weight adjustment, you're multiplying the input value by the delta that's here. So you backpropagate delta, you have delta on the hidden layer. So the way to update these 4 indices, you say 1 times the delta that's right here, and you subtract that from these weights. Now, the thing is, if it's a 0, that subtraction is always going to be 0. So we can skip that on the way back as well, which is great. So that's how we do our weight update. All the evaluation logic is the same, the test logic is the same, the run logic is the same. And now we want to try it out. So we're going to go ahead and grab our MLP sentiment network, put it right there. Then we're going to grab the actual training. So just for reference, right, this trained at around 100 reviews per second. Go ahead and run that, put that right there, grab the test. I guess we run the train. Grab the test. Oh, I guess we kind of want to see that. So we'll see in a second. 1,000 reviews a second. It's 10 times faster. Over 10 times. Look at that. 1,300. And it's still training with the same convergence speed. Look at that. 1,300 reviews per second. That is over an order of magnitude increase in speed because we got rid of all these fixed problems. Like, let's see testing. Okay, testing, you almost didn't even notice it happening. Cool, awesome. And we're getting a great score. Actually, yeah, it should be exactly identical, right? Because nothing has changed. Man, this is great. That's so much faster. Awesome. So this is great. If we wanted to, we could train multiple iterations, right? So if I said times 2, so we'll hit train, and second it'll get started. So it's converting everything into indices right now, and then it's going to start training. So I guess maybe I lost a little bit here. But if you're going to keep doing more iterations, it's going to use the same indices. So it converts the indices once, and he's going, wow, reviews per second is cutting up to 1,500. It's crazy fast. So we can keep training. Training accuracy keeps going up. It's just, the faster your network goes, the more iterations you can do in a given period of time, right? And the way that we are able to accomplish this is by just stripping out the stuff that the neural net is doing that actually isn't helping us predict or really even to learn. That's really what this strategy was all about. So yeah, now in the next section, we're going to kind of go back to our data and say, okay, can we kind of improve the modeling again? So we improved the way that we frame the problem. Then we improve the way that the neural net is forward and back propagation because of how we train the problem. So like because we set up just pushing forward the vocabulary, this allowed us to trim out a lot of inefficient waste that the neural net was computing. And now we're going to go back. Okay, can we reframe the problem again to reduce even more noise and potentially even reduce more weight propagations we have to do to speed how fast it learns and actually how fast it computes. So we're going to do one more iteration of this in project 6. I'll see you there.